Hello and welcome to the learning part. Before I get to the learning part, if you find problems or errors or something doesn't work or a link is broken, just email me. Just RYoung at UNLV. Just email me and I'll look at it. I copied some of the stuff over from a past class and that created a bunch of headaches for me. Also, I can't always view things until it's opened up, so I can't really test things. Like if I go here and it will say like access denied. Yeah, the page has been disabled for this course. So I can't really, do a whole lot until the class is live, and by then you guys will find bugs. So if you have problems, let me know, and we'll fix them. So that's number one. Number two, we have this this thing here on campus, the National Supercomputing Institute. From what I understand, when we used to have nuclear testing underground, and Congress said, no, you can't do that. Well, they spend a lot of money on supercomputers to model those explosions. Hence, that's where this came from. They have a bunch of different computers, research computers, all types of nodes, a bunch of different things. And it's not even up to date. They have a dedicated network to switch, all types of stuff. The guy that runs it, Joe, I've known for probably 10 years, if not more. Super great guy, and he's just done so much for this NSCEE, the Supercomputing Center, that I can't say enough about all the good things he's done. Well, I asked him if he'd be willing to give a tour to a couple of my classes. He's like, yeah. So if you guys want, we can get a tour of this. It's completely optional. What I did is I put in a discussion, NCSE tour. It's February 9th. There's one tour at 1 to 1:30 and another one from 1:30 to 2. Again, it's completely optional. It's just sometimes it might be nice to see actually, what a big cluster looks like. There's all these different types of computers, and it's sometimes hard to really kind of comprehend what they look like. So just click on this link. I've never done a Doodle sign up. It's, I guess, like Google Forms. You just pick the date you want to go, and I guess confirm, and probably ask you for a name or something. Oh, I guess because I'm already logged in, that's why. You might have to sign up. I don't know. Just let me know how it works. We can only put 15 people in each group, so I'll have to go take myself off, but there's that. There's also a topic. If you have questions here, just feel free to ask it. If this one's really popular, I can set up another time. Just let me know. So, a tour. So that's covered. If you have any problems or errors with a website, just let me know. I'll fix them. Again, it's hard to test until it's live, and then I guess let's begin. No time to wait. Looks kind of stretched out. So this is the first week, chapter 1 through 3 of this book, and I'm all the way through 3. And I'm not going to lie to you, some of the stuff's kind of boring, but it's so fundamental and so valuable. Please pay attention, because without these core concepts convert or carry over to every different subject, every different task, every different class, and so many different things. So it is important that we pay attention to really, really understand the fundamental core concepts. So like I said, we'll cover chapter 1, 2, 3. The discussion posts are up and live. Just tell me a little bit about yourself. Feel free to share a little or as much as you want. And there's no homework for this week. So I love this quote. Without big data, you are blind and deaf in the middle of a freeway. I had another quote somewhere that I really enjoyed too. It was much longer. It's like companies that don't use big data, they make like 60% less money and are like 90% more likely to fail within 5 years. There's just some research by, I think it was Gardner or somebody, about how companies who don't use their data don't do well. And it's hard to imagine, but I mean, can you imagine going through life without knowing how much money you got paid, without knowing how much money you're buying things from, how much money you have in your bank account? I mean, that's the type of blindness that companies sometimes have a problem with. And the questions that I answer sometimes are really simple. Again, I work in healthcare, but sometimes it's like, how long is a visit for a patient? What are the most common things? that a nurse may see a patient for. Does this actually work? We just found a study that a particular type of medication, a particular type of surgery, okay, is no more effective than medication. So basically, the research showed that, hey, if we put a pain pump in your back to prevent you from taking certain types of drugs, fentanyl and super strong drugs, it doesn't work any better than if we don't do anything. And so now, the insurance company spends thousands of dollars. The patient is in pain and surgery for, I don't know, 6 months without a job, and there's no positive benefit. There's no positive outcome. Other times, we find small little things make huge differences. So, understanding your data and asking the right questions are so valuable. Let's keep going. Now, where does big data come from? Now, it matters, but it also doesn't matter. And the size of big data is one of those relevant things too. So what might be big data to one company or one person might not be big data to another company or another person. Okay. I've worked with teams where anything that doesn't fit in an Excel spreadsheet is considered big data. And then other teams where if it doesn't fit on, basically a server, a localized server, then it could be considered big data. So it's very hard to answer what is big data. And also, where does it come from? So Facebook, Twitter, these are social media feeds where people generate content that's stored. And a lot of people generate a lot of content. The Internet of Things, especially sensors. I don't talk a lot about it, but sometimes sensors that continually transmit data collect a huge amount of data. So my phone, right here, it's, I think, pinging probably 3 or 4 cell towers right now. So it's talking to 3 or 4 cell towers probably every second and sending basically a heartbeat. And it's been doing that for, I don't know, I've had a phone for 20 years. That's a lot of data in itself. There's sensors out down the street from where I live that collect weather and rain. It's just a lot of those sensor data collects a lot of data. I work in one of the labs I work in, we collect brain readings. And we're sampling at 60 hertz or 120 hertz. So we're collecting 120 times a second. And we're collecting 10 rows of data. So, when we collect 5 minutes worth of data, we have thousands and thousands and thousands of data points. And it's all sensor data. Business transactions. Every credit card, location, all that data is stored somewhere. Digital contacts and pictures. We'll talk about this one in a second, but that's been a big boom towards big data. Public records and governments. Regretfully, public records and governments haven't moved online as fast as they should. They're not incentivized like corporations to move online. There's still a lot of data in governments. You can go to data.gov or data.gov. I think it's data.gov. Yeah, data.gov. 200,000 data sets. So there's just a ton of data out there too. Scientific research. I worked in, biology stuff. So that data gets really big really quick. And again, healthcare. Healthcare is one of the fastest growing areas. And boy, it's data on data on data, and it's more data. So, MRIs or, X-rays, ultrasounds, all that stuff creates a huge amount of data. And, I want to give you a demo of this, and it's hard because we can't imagine. Humans are very bad at imagining numbers and data and things like this. So this book, on the PDF form of it, is about 12 megs for my copy. It took somebody 6 months, probably, and I'm just spitballing, but about 6 months to make that book. Now, and how many people can create it? Maybe 1,000, 10,000 in the world? That's a lot, and they create 12 megs of data. And, with backups and pictures and edits, it might be 100 megs. Okay? Now, during Christmas, I shot a picture of Lucky. It took me 1/10 of a second. And it's what? It's about 4.6. I just did the calculations. It's 4.6 times bigger. So even just by that one metric, 6 months versus 1/10 of a second, and it's basically 5 times bigger. So that shows you how we're getting into this huge big data world. And the thing is, millions of people have iPhones. Not millions of people can write a book. I guarantee you, more people can take a picture with an iPhone than write a book on big data fundamentals. Okay? And I mean, the thing is, you can just click, 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 and take thousands of pictures. Where's camera? Let's see if I can go here. That's so I don't know if you can see. Let's see here. I mean, there's 40, 50, 60. Just look at that. It's just counting up, taking pictures and pictures and pictures. And that's hundreds of megs of data compared to 6 months for a book. And this wasn't possible 6 years ago, so that's where a lot of the big data comes from, non-traditional sources. This slide goes a little bit more into detail about it. When we really hit the beginning of the digital age in the early 2000s, and I bet that this pipe or funnel is considerably bigger than what it is. Okay? And I've looked at some of these numbers. I have no idea if they're true. Hey, 19 exabytes, 280 exabytes. There's a quote from Google. Hey, we're creating 2 zettabytes a day or something. I don't know if any of those numbers are true. And honestly, it doesn't matter. What matters is that, we're creating more data every year than we did last year, than 2 years ago, than 5 years ago. We're creating it faster. We're trying to store more of it, and for a longer term. It's a lot of data. I really don't think many people understand how much data it really is. Now, the book talks about the word data set. So a data set can be really anything that has some type of logical organization. If I have a collection of pictures of my dog in a folder, that's a data set. If I have a very specific transactions at a particular business on a particular day, that can be a data set. Okay, a data set is any type of logical organization of information. It can be picture or even data. Sorry, logical organization of data. If I have a bunch of pictures of birds and I'm going to go bird watching, that's a data set. It could be a collection of books. So it's just a collection of some type of data with some type of, at least logical in your brain, organization. Now, it could be dirty data, meaning it can have bad data in it. It could be missing numbers. It could be cleaned. It could be on a database. It could be on a flat file system. Or it could be on a folder. So don't get overly worried about really what the data set is. It's just some type of collection of data organized by some type of organizational unit. And data analytics is just taking that data and doing something with it, hopefully deriving information, knowledge, taking it to the next level. If I have a bunch of transactions for one particular business for one particular day, maybe I want to know how much sales they made. Maybe I want to know who's the best salesperson. If I have a bunch of pictures of the dog, maybe I want to know what picture of the dog is most popular. That's kind of data analysis. As I talked about in the syllabus, this gives us a little bit better information, but this basically shows how we can, let me switch this over. Give me 1 second here. Okay, so right here, if we're really to think about this, okay, I'm counting the TV or the marker. There we go. So right here, right there. So this is kind of what happened. Sorry about my writing. And this is what might happen. Now, they're both equally important in some ways, but as you go up here more, it becomes harder and harder to do. Okay, if I was to ask you, hey, how much sales did this business make 4 days ago? We can do a sum, and boom, we got that. If I ask you, hey, how much will the business make in 4 years? That's a little bit more tricky question. Okay, so your book kind of covers. I think your book covers these, but at the end of the day, these are the 4 levels of kind of analytics. Descriptive. It basically just describes, hey, this is a sum, this is a mean. Do I have it on the next one? I don't. So this is a sum, a mean, things like that. Diagnostics, maybe what, why did it happen? What happened? What was the number one selling product? What day of the week was the best selling day? Predictive analytics is when, it's hard. I'm trying to think almost exact terms. So if we're looking at a restaurant, we say, hey, on Sundays, well, the last 3 Sundays we've been busier than any other day of the week. Maybe next Sunday we'll be busier. And then how can we make it happen again? What in that particular Sunday, was it a different type of food? Was it a different waitress? What combination made that happen? And there's different ways to do this. There's a random forest. I mean, there's all different types of methods to kind of do this. Okay. Let me switch back over here. So now, again, I hate job titles because they never really explain anything. I know data scientists that do nothing but work back here, and I know data analysts that do nothing but predictive analytics. But, I want to kind of prepare you for, hey, we're looking for X, Y, and Z. This is kind of the way it works, okay? Data architect, those are, normally DBAs or data engineers. They're not really called data architects, maybe they are, but they're mostly DBAs or data engineers, okay? Data analysts basically get the data, maybe clean the data, maybe do some light forecasting, but mostly stick in the past. Hey, this is what happened, this is why it happened, blah, blah, blah. Data scientists, at least from my understanding and my thoughts, they are asked to do reports a lot, and they also try to predict the future, extrapolate to the future. They try to answer questions that are unknown. Where data analysts try to answer questions that are kind of known. Let's keep going. Descriptive analytics. Let's see what I wrote here. Descriptive analytics is used to summarize and interpret historical data. Yeah, so mean, mode, trends, patterns. I thought I had all this written down. Examples of descriptive statistics would be company's annual report shows the total sales. Then diagnostic analytics, the reason for past performance. So data discovery. Hey, we did. I don't know if you've heard of a chart, 80-20. 80% of our sales come from 20% of our product. Or maybe on one particular day of the week you have a certain type of cheesecake, and other days you don't. Maybe one particular brand of cars is selling better than all the other brands of cars. Okay. If you look at Steve Jobs. When he first went back to Apple, they had like 19 different computers that basically all did the same thing, just slightly different versions. He got rid of all of that. He wanted super simple. He's like, hey, we need like 3 computers. So Steve Jobs basically just kind of streamlined all the business operations. I'm starting to see it with Apple kind of spreading out a little bit more, getting more products, but they really don't need them. So this is kind of the diagnostic analytics is, hey, what's really selling? What's really working? Why did that happen? Okay. Now let's go to predictive and prescriptive analytics. Predictive analytics is used to make informed guesses about the future. So these might be statistical models, regression, machine learning. An example of predictive analytics is retail company making customer purchase history, and demographic information to predict future buying behavior. So, the last 3 years we've sold X number of jackets, like winter jackets. Maybe this year we're going to sell, 10% more. So then prescriptive. Now prescriptive, you don't really hear about this per se in the business world, but it's the next level. We're going to talk about information and knowledge and wisdom in a little bit. And this kind of gets that idea. but it's doing more than just predictive. It's, optimizing. Okay. A good example of prescriptive analytics is a logistic company optimizing delivery routes. The analytics stem from not only predicting traffic patterns and delivery times, but also prescribes the best route for deliveries to minimize delivery times and fuels. So, you see a lot more companies trying to get into this. And this is where big data comes in. Because without big data, you can't do, you can do some predictive analytics. It just might not be as accurate, but really prescriptive. You need a lot of data. Okay, again, that's one of those nebulous terms. I taught business intelligence. I know some of my students are here from last semester. I appreciate that. But business intelligence, at least in my mind, at the end of the day, is, hey, getting answers to questions that drive business, that have value, turning data into knowledge or money, sharing information and then following those outcomes. Okay? You go back here, it's nice to know that next quarter we'll sell 600, puffy jacket, flannel shirts. We'll sell 600 flannel shirts. That's good to know. But prescriptive analytics could say, hey, we could sell 800 flannel shirts if they were plaid. We could sell 300 if they were solid green. Okay, and not only that, if we put this type of sales around it, it looks like it will increase our sales. Maybe like, a cowboy with a flannel jacket. Where if we have a guy in the urban Starbucks, it won't sell as much. So this is how, data goes from prescriptive to predictive and predictive to prescriptive. It kind of floats back and forth. So and that's where business intelligence is. Now, your book talks about these V's, and it's a nice concept, but it's very general, okay? And there's all different types of V's. So, in a nutshell, when we're working with a project, we always have to think about a lot of things. And the V's are just kind of, in my mind, a checklist of what we should be thinking about. Okay, we'll go into these in a second, but how fast is it coming? This is the 3 V's. How much of it's coming in? Is it very structured data? Is a bunch of pictures? Let's go on to what the 4 V's. You see why I don't like this kind of nebulous academic kind of stuff some days. Okay, let's go to the 5 V's. Volume, value, veracity, variety, velocity. Well, look, we've got the 6 V's. Keep going here. We added value. Is the data worth something? Is the data useless? Ooh, we got the big 8 V's. I think I even found one that has the 56 V's. So the takeaway from this is that when we're working with a project, we have to kind of think about the data we're going to get. Is it going to be a one-time analysis? Hey, here's a bunch of data, just process it, and you don't ever have to worry about it again. Well, that would be nice. Is it going to be a quarterly report? Is it going to be a daily report? What type of data is it going to be? So the volume, let's go over a couple of these real quick. So the volume data, how much is really needed? I worked on a project where we did a bunch of ultrasound. It was a ton of data, not very many patients, but just a ton of data because there were pictures and videos. They were technically videos. They were cines. So the volume of data was very high, but the velocity was very low. It was 10, maybe ultrasounds a day. So I'd run a whole month at a time. It just wasn't coming in that month. Now the value of this data was phenomenal because they were trying to not get rid of cardiology, but optimize the cardiologist's job. And I don't know what a cardiologist make, but $300,000 or $400,000 a year, maybe $500,000 a year, and there's probably 8 of them. So that's millions of dollars a year. This data was very, very valuable. A lot of volume, very slow incoming, a lot of value. Keep going. The variety, the data was pretty much kind of all the same. The readability of the data was impossible. It was very hard to work on. Where is the data going to go? Is it going to be in a database? Is it going to be online? We look at Twitter. There's a ton of data. It comes in every second, thousands of tweets a second. But now, what's the value? I mean, if you could scrape every tweet for the last 24 hours, really, what would it show? What would be the value in 2 years of that? I don't know. You know, the tweets would be all, from who it came from, where it was tweeted, maybe some GPS data, and the tweet. I mean, it's all structured data, you know? So, speaking of structured data, and your book talks a little bit about semi-structured, but let's really break it down to two parts. You have structured data and unstructured data. Structured data is anything you put in a database, anything that you put in Excel, database record, financial data, I think that's spelled wrong, retail sales, any of that stuff's just, rows and columns. Now, I read somewhere that 80% of the world's unstructured data. I'd be willing to bet that's probably more than that. And I say that's where the money is unstructured data. Now, what is unstructured data? A picture. That picture of Lucky and the picture of the book, if I wanted to search this book, it's a PDF, even though it's kind of structured, I could, put it in Acrobat and search for the word network. Okay? Would it be hard? And it's unstructured data, but still it's searchable. But now, if I had, 1,000 pictures, and I'm sure I have 1,000 pictures, and one of the words have network in it somewhere, how would I search 1,000 pictures for the word network? It becomes a much more complex problem. What if I had a TV show, or let me rephrase it, a friend works for a company, and what they do is they search online news sources like, KBLS, or, all these news sources. They get all these feeds, and then companies hire them to look for their logos and their phrases in news feeds. So if I'm Kodak, let's say I'm Eastman Kodak, and a reporter in Washington, D.C. says Eastman Kodak I would get an alert. But think about how much more difficult that is than just opening a dictionary and looking for the word Kodak. But now, think about the advantages. If you're Eastman Kodak and some reporter says something bad or says something good, now you have insight. So literally, a lot of companies are trying to figure out ways to do this. Take this massive unstructured data and add business value to it. Now, your book talks about metadata, but I can't stress how important metadata is. Let's switch over here. One second here. Okay, so metadata is information. I always think of it as wrapping the data. Now, that's not necessarily true, but if we had that Eastman Kodak and the news reporter, the metadata would maybe be the reporter's name that was on the KLS or the news station that said it, maybe how long the newscast was, anything besides actual data. Okay, and it's kind of hard to originally wrap your mind around this, but there was a book, I think it was maybe David and Goliath by Bruce Slostor. I can never say his last name. He said, hey, the NSA basically couldn't listen to American cell phone conversations, at least legally. But it turned out that there was more value in the metadata. What do you mean by that? Well, if I'm a terrorist and I use my phone to call somebody and I use codes, oh yeah, the piggy is going to the bank. The NSA might not ever really be able to figure out what those codes are. But what the NSA did is they noticed that when two people go to a cafe and turn off their phones at the same time, that's the metadata, your phone's no longer transmitting, and that person's phone's no longer transmitting. And then I go somewhere else and my phone turns back on, and he goes somewhere else and my phone turns back on. And then my phone turns off again and somebody else's phone turns off. They can infer who I'm meeting with. They can build a network of terrorists with no information. Just when your phone came on and when your phone turned off, compared to who else around you turned the phone off at the same time and who else turned the phone on at the same time also, which is crazy. And I guess that this information is just super valuable. When you turn your phone off and when somebody else turns their phone off, it doesn't matter what they say. Now they know you two are working together. And then you turn it back on, and then you go somewhere else and you turn it off and some other third person turns it off. They can build a whole network. without ever listening to a call. So that shows you the value of metadata. Stolen devices. If your phone gets stolen, or documents. There's forensic document evidence that are like JPEGs where images are taken. I cannot stress how important metadata is in this new world. EXIFD is information about a photograph. How big a video is. How do we compare? If I had 10 videos on my computer right now, how do I see if they're the same video or not? Well, if they're 2 hours long and they're all the same time in the exact seconds, it's not a great indicator. But I can infer that, hey, 5 of these videos have the same time, the 6th one doesn't, and they're all the same file size. I don't even need to look at them. I can just say, hey, 5 of those files are the same. They're the same length, same size, they're the same. That's metadata. And the value of metadata is increasing a lot. Okay. So let's go to chapter 2, business motivations. The goal is to turn data into information. Okay, now, this may seem obvious, but it's not. A lot of companies and a lot of people collect data for no good reason. They just collect it and collect it and collect it. The companies that are successful take that data and do something with it. Okay? This is the data, information, knowledge, and wisdom pyramid. And this is a basic concept that we need to understand. There's another slide that I love about 10 times more than this. Basically, data is, any raw information. I wonder if I put that slide in there. Let's see. Did I put it in here? Oh, I didn't. Sorry. Okay, so data is knowing, hey, I've gone to McDonald's 600 times in my life. Information is knowing, hey, every time I go, I order a Big Mac. I know it sounds really crazy. That's the only thing I think of off the top of my head. Knowledge is knowing, hey, every time I order a Big Mac, I also order fries, maybe with no salt or something. I don't know. And then wisdom is saying, hey, next time I go to McDonald's, I know I'm going to order these things no matter the price. No matter the price, but you know what I'm saying. That's kind of the way we always have to think of things. Data is almost useless in a lot of ways. We prescribe, or we get information from data. It just adds kind of meaning. Once we move up to knowledge, now we're talking about something that we can understand, we can interpret, we can wrap our minds around. Wisdom is taking all 3 levels below and doing something with it. Data is a raw word, so the letter D, the letter J, the comma. That's data. Information are the words. Pyramid, well, I know what a pyramid is. General, I know what general is. Knowledge, well, knowledge would be a sentence. So let's see, the vital model shows how raw data can be transformed into valuable insights and wise decisions. Okay, I get it. Now, wisdom. Well, you know what? I could use the same thing here to change my gym workouts. I could take the data, my weight, how much I'm lifting, turn that to information. Well, I know that I'm doing X number of reps, and I could apply this to other things. That's why I like this slide so much better. Okay? You can operationalize, track metrics. You can get your key KPI. My brain just totally forgot what KPI is. And you go KPIs, and your strategic planning. Those are wisdoms. Okay, once you apply wisdom to it, say, hey, this is how I want to make a change. I want to try this new business. I want to do this. Instead of having a round wheel on Tesla, I want to have a yoke, I guess. We make actions. We'll change it. Experiment. Does it work better? Does it work worse? If it works worse, let's go through and change this. Last semester I talked about lean. A lot of this comes from lean methodology, Sigma 6. We're taking something, we're adding information to it, we're looking at that information, we're trying to convert it to knowledge, and we're trying to make an action on it. This pyramid here, to me, this one I don't think is in the book, but I think the other one is so vital, because this is the way that businesses succeed, or this is the way businesses fail. Right here is how businesses succeed, startups from billion-dollar companies where they fail. So Here's another example. Data, if you look at this raw ingredients, hey, we have eggs and sugar. We take those ingredients, data, and we follow a recipe. This recipe tells you how much of each ingredient to use and what to do with them. So, hey, you add eggs and flour, blah, 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 and you start mixing them. And knowledge you gain through experience or education. So now we know how to make a cake. And you know what? We make the cake again and again, and it's great. But you know what? Maybe I have a new girlfriend or boyfriend, and they're gluten intolerant. So instead of using flour, instead of using wheat flour, I have to use a gluten-free flour. So I have to use my knowledge and infer that, hey, this is how it's going to change. Data, information, knowledge, wisdom. This should apply to everything that you work on, everything that you do. Your book talks a little bit about types of cloud computing. And cloud computing has kind of fundamentally changed the way we process data. Okay? So let's dive in a little bit more. On-prem means I have the physical server. I have an iPad here, I have a computer over there. I physically have access to that machine. So if I physically have access to that machine, or I physically own that machine, what do meaning the company, meaning the management, meaning something, what do I manage? Well, the application, the data, the power, virtualization, I manage everything. It means a lot of people are going to do a lot of things if I have a lot of computers. I mean, how many people is it going to take if you have 1,000 computers, 10,000 hard drives, 1,000 CPUs? It's a lot of work. Now, infrastructure as a service, okay, that is where it's not just called bare metal. See, bare metal as a service or metal as a service. It's when they manage everything except for the actual machine. So they give you the hardware, they give you the power, they give you the network connection, they give you everything and say, hey, here's a basically server that's ready to go. Okay, again, more expensive than I guess maybe on-prem, but again, you're saving staff costs. Now, platform as a service. So let's think about this. On-prem, we manage everything. Infrastructure as a service, they manage everything basically until the plug, to the computer, to the operating system. I have to manage maybe the OS in terms of installing Windows or installing software. Things like that. I have to manage my data. I have to do backups. I have to worry about virus scanning, things like that. Now, platform as a service. Platform as a service. And so now I just have to worry about the application and the data. Okay, so that is, I'm trying to think of, what do we have over platform as a service? Platform as a service. Heroku. That is a service where you go and say, hey, I need a database, and it gives you a database, like a Reddit database or an SQL database, things like that. Okay, I use it for one of my sites. You say, hey, I need Rails, I need an email, like a send it grid. You ask for these things, and basically they turn on, and boom, you send it data, and it starts processing. Now, platform as a service. Do they have that one over here? No, we don't. I guess we do. Platform as a service, all you really have to worry about is your application and your data. They guarantee uptime, they guarantee everything else. Okay. And then finally, software as a service is you basically get like, you basically log in and just work. I guess the best way to do it. There's like online virtualization. Office 365, I think, was the reference they used in the past. I used to use Amazon, I think it was Workspaces. Basically, I just turned on a client and boom, I booted up my computer and everything was installed and ready to go. Okay, so these are kind of different levels. I think we only cover about half of chapter 3. I have to look at the syllabus, but again, it's hard because big companies versus small companies versus the type of data. So big data to a tech company might be very different than big data to a farm. Okay, so we got to keep that in mind. Big data to a small doctor clinic versus big data to Optum is completely different. We have more healthcare data than Google. So privacy, is our data in compliance with the law? GDPR, HEPA, PCI. There's a bunch of them. Are we being responsible with our data? Are we being reasonable with our data? Data procurement deals with how we get the data. Is it good data? Is it somebody entered the data? I saw a picture I was going to use for this class with a JPEG is corrupted in the middle of it. Is there bad data? Security. This is another big one too. When a lot of companies move to the cloud, they don't always understand. Go back here. But somewhere in this transition, they lose sight of how to secure things because it's not physically in front of them. Because they're not hiring now expert people to maintain these things. Because here you have to have a bunch of engineers that you're paying $100,000 a year, $200,000 a year to make sure these things are working and stable and good. Well, you fire those people and you move over here, you don't have to worry about it. But the problem is, or let's say you move right here to platform as a service. The problem is your data secure? Well, you don't have the domain expertise all the time to know that. So that's how a lot of security things happen. If you look on the internet and look at big data leaks, a lot of them are just databases people forgot to add names and passwords to because they're online. Provenance, where the data come from. Big data performance. I told you I had 400 to 500 terabytes online. I had a special connection at UNLV, a 10 gig connection to move that data up there. I could never do it with a 100 meg connection. How long does it take to move that data? Is it a fiber optic connection? Is it a 100 gig connection? Is it a 1 gig connection? It's a really important thing to think about. Big data versus real-time data. So there's something called Amazon Glacier. Amazon Glacier is offline storage. So you have maybe some big data or just data and you want to back it up. Amazon Glacier is really cheap. The problem is if you want to retrieve that data, I think it takes, like 24 hours, 48 hours. Sometimes that's not enough. Where if you have a cloud distribution, a CDN, content distribution network, let's say that, you can have a JPEG and you spit it all over the world and it's almost instant, but it's very small amount of data. But it's real time, it's live. There are different ways to process and understand this. So again, like I said, I didn't go a whole lot into chapter 3. We can go over that if anybody has questions. I just don't want to make this video too long. It's already 40 minutes. So the demo, there's going to be a demo of how to set it up. Sorry, I know there's a lot of videos this week. I promise it's not going to be like this. It's just I want to hit the ground running. I want to get through some of the boring stuff. Once we get through some of the boring stuff, we can move to the fun stuff. So the demo on how to set things up hopefully is 10-15 minutes. Discussion, just tell me about yourself. Quizzes, don't worry, you can take the quizzes a million times. I think the answers are all true. Just true. Basically, hey, you read the syllabus, you understand the syllabus, you're going to use ChatGPT in this class only. And the setup quiz is, hey, I set up Colab, or I have a Colab account. I set up Hugging Face, I have a Hugging Face account. Maybe Colabs, I'm not sure. GitHub. So, easy peasy. And don't worry, I know this seems like a lot. Trust me, I know, because I have to do all the work for getting the videos and the PowerPoints. I know it seems like a lot, and it is. Things will normalize. Things will slow down. We'll have a normal week next week. We'll have a normal week after that. Things will get better. Don't stress. I'm here to help you. Okay? Hopefully you have a good week, and I'll talk to you later.